Welcome Math 136 students to the Module 03A Problem of the Week. So for this week, you're going to be doing working through problems where you're going to be applying transformations to functions. And so what we're given here in this problem, and I believe you have 3 of these on your homework assignment, you have a function that is not in the form where you can readily identify the transformations. So what we need to do is convert this over to a form that allows us to identify those transformations. Now, the good news is they're giving you a hint on how to do this. It's completing the square. So that's what we're going to apply to this quadratic function in order for it to be in a form that we can identify the transformations. So the first step in doing this is to factor the coefficient of 3 from the first 2 terms. So you want to factor it from your quadratic and your linear terms. So that'll be 3 times the quantity x squared minus 4x and then plus 16. Next, we're going to apply the completing the squares process here. So what we want is a term, a constant inside these parentheses, which will allow us to then have a perfect square trinomial. Now that constant can be found by taking b divided by 2 quantities squared, and b in this case is -4. So when you take -4 divided by 2, square it, what you get is plus or +4. So that constant of 4 goes inside the parentheses. Now, when you were solving a quadratic equation by the completing the squares process, you would have then added a constant to the other side of the equal sign. The challenge here is that we're doing everything only on one side because we're dealing with a function, not an equation that we're trying to solve. So in order to keep the function balanced, in order to maintain the exact same function and not change it, we will have to then subtract a constant to the same side. So we're adding a value and subtracting a value, so the end result will be that they can cancel out if we were to simplify and go backwards. Now the other challenge is that some people would like to put 4 here. Well, no, that actually is not going to work, because if we distribute the 3 to everything inside the parentheses, that value is no longer 4, it's actually a 12, and so that is the value we need to subtract on the outside of the parentheses. So again, if we were to simplify and distribute the 3, combining like terms, we would now be able to go back to the original function. So again, this value right here was the 4 times that coefficient, that leading coefficient of 3. So next, what we're going to do is factor the quadratic expression. So we have f of x is equal to 3 times x minus 2 times x minus 2. And then we can combine those two like terms to get plus 4. Now since we have x minus 2 times x minus 2, and anytime you have something times itself, we can actually rewrite this as f of x is equal to 3 times x minus 2 quantity squared. And now we have our transformations. So we know based on this form that we have a shift or a translation, horizontal translation to the right. We know based on this form that we have a shift up 4 units. And then finally, we have one additional transformation, which is 3. And that transformation is going to be a vertical stretch by a factor of 3. If that 3 actually was between 0 and 1, it would be a vertical compression. So now that we know all that information, let's go ahead and plot our graph with these transformations. And the first thing I'm actually going to do is plot the basic quadratic function. So in other words, y equals x squared. I'm going to graph that and then apply my transformations. So I know that for y equals x squared, my graph will have the vertex on the origin. It will have a point at 1, comma 1 and -1, comma +1, and it creates a parabola. So that is the graph of my basic quadratic function. I'm now going to start by applying the vertical stretch to this basic quadratic function. So all of my outputs get multiplied by 3. So my output at the origin is 0 multiplied by 3. It stays at the origin. My output at +1, multiply that by 3. I now have an output of +3 for both of these points. So you can see how the graph now has stretched vertically. It's getting closer to the y-axis. And then I'm going to shift to the right, and also up. So this will be my final form. And I'm going to do this with all the points that I've graphed in the pink color. So I'm going to shift to the right 2 units, 1, 2 units, and up to the up 4 units. 1, 2, 3, 4. So my final answer will have a vertex at 2, comma 4. And then I'm going to plot my other 2 points because I want to have a general idea of the shape of this parabola. So I'm going to plot my other 2 points by again going to the right 2 and also up 1, 2, 3, 4, and to the right 2 up 1, 2, 3, 4. So my parabola looks like this. All right, guys, I hope that that was helpful. And again, that is trying to graph using transformations a quadratic function when it's not given to you in a form that you can easily identify the transformations. All right, guys, good luck.